Hey everybody, in this video we are going to be talking about how to calculate percent of change. And I've got some vocab here for you guys in a second, but first let's just put the pencils down and kind of just think about this for a split second, okay? Let's say you're at the store and you have a $5 off coupon, okay? So $5 off. This could also be like a promo code online or whatever. But if the item that you want to buy costs $20, I want to know what percent discount $5 off would be. So if you're going to save $5, you're going to discount $5, and the price is originally $20. You're saving 5 of 20. So I want to know what part that is, and you can see here that that reduces to a fourth. So basically we are saving 0.25, or it's a 25% discount. It's decreased by 25%, or it's 25% off. That's another way to think about it. So decrease of 25% or 25% off. Now this isn't in your notes. This is me just getting you guys thinking about a percent of decrease here. And to calculate it, what we really did was we just took the difference, okay, and divided it by the original. So you're going to see that today in our video, in our lesson, and I just kind of wanted to start with just kind of a basic, easy problem so that you understand we're talking about what part the discount is of the original price. And this will actually work for a lot of different types of problems, not just money problems or discount problems, so that's what the video is about. So let's go ahead here and get some definitions down. So the percent of change is officially defined as a simple mathematical concept measuring the degree of change over time. So like change over time. Now there's two different percents of change. It could either increase or decrease. And what we mean by that is if your new amount is more than how it started, clearly it increased. But if the new amount is less than the original, then clearly it decreased. All right. So again, if your amount is more than the original, if the new amount's more than the original, it came up. If the new amount is less than the original, it came down. So if you gain weight, your new amount is more than how you used to weigh, that'd be a percent of increase. If you're losing weight, it's because your new amount is actually less than what you used to weigh, and again, that's a decrease. And as I mentioned over here on the green slide, that items on sale are a percent of decrease. If something is on sale, it came down by a certain percent, so that's a percentage of decrease example. Now here highlighted in green, I have the formula that you want to put into the box. And what that formula does is it calculates the difference for us divided by the original. So in all these problems, I'm going to walk you through how to spot the newer number versus the original starting number. And then we're going to subtract to get the difference, and we'll always divide by the original. Now with this lesson, I like to talk about what you already know and how we're going to kind of use that to make sense of what we're learning today. So something that you already know how to find a sale price. We did that when we learned how to find discounts. And so let's take a look at a problem here. Again, this is something that you already know. If something costs $34 in the store and is on sale for 30% off, how much will you pay? So to do the math here, you would just take the discount, which is 30%, and you'd multiply that by the $34, and that would tell you how much the discount is. So let me get my calculator out. All right, so we're just multiplying my 30% times the price of the item. So I'm going to save $10.20. I'm going to save $10.20. That's my discount, $10.20. So if I save $10.20, then my sale price is going to be the $34. I'm going to pay 34 minus $10.20. So in your calculators, you can just do 34 minus $10.20. And we'll see that I'd end up paying $23.80. $23.80. That's the sale price, $23.80. Dollar sign's a little messed up. There we go. All right, so that would be the total cost. So we know how to do this. Now let's take a look over here at how it's basically the same setup. I'm just asking something different, okay? In this case, I want us to find the discount rate. So we're trying to find the 30%. We're going to prove that the discount was a 30%. Again, we already know it from over here, but now we're going to prove that the percent of decrease, the discount, is 30% off. And to do that, we're going to take the new price minus the original and divide by the original. So if something originally cost $34 and you got it on sale for $23.80, that's the new price right there. $23.80 is the new price. So I'm going to take $23.80 and I'm going to subtract the original price. And I'm going to end up dividing by the original, so I'm going to go ahead and put the 34 there as well. Now what this does is it gets the difference. It gets the difference for me. It tells me how much I saved. So again, in your calculator, if you do $23.80 minus the 34, it's going to say, see, it's negative. You saved $10.20. So it came down $10.20. And you're going to divide that by the original price. So again, the difference is you're saving $10.20 divided by the original. And when I do that in the calculator, if I divide this now by the $34, boom, you can see it came down 0.3, which means it came down 30%. So this is a down 0.3. Or again, you can say down 30%. And without a symbol, you could also just tell me with words that it's 30% off. So if I ask for the discount rate, you're basically telling me here it's 30% off. If you use the word off, don't put a negative. If you're not using the word off, make sure you put the negative to show me it came down or is off 30%. So that's how these kind of work together. We're taking something that you've already kind of learned, and now I'm giving you the original price and the sale price, and I'm expecting you to be able to find this discount. That's what happened over here. Okay? So let's practice how we can use this formula to calculate the difference and divide it by the original. Let's take a look at this first problem here. You can see I've already got the answers already lined up for y'all. So a Garmin running watch originally cost $330 online. And I was able to purchase it on a Cyber Monday for $250. So I want to know what percent was the watch discounted. So again, if I got it for $250, that's my new price. And it was originally $330. And if I subtract those, it shows that I saved $80. That's the difference. I saved $80. Now if I divide that by the original cost, this is going to be the decimal we get in the calculator. So let me do my down by 80. So I've got 80 down, $80, divided by the original 330. And you can see right there, that's where I got my 2424 repeating. And if I make this a percentage, notice that this 2 is not going to round. It's not enough to round this up to 25% off. Okay? So we can see here I saved almost 25%. That's a really good deal. Now, at any point, y'all, if you want to pause the video and try these problems on your own instead of looking at the answer, feel free. But I'm going to go here now with the next problem. Anne works in a supermarket for $10 per hour. And her pay was increased to $12 an hour. And I want to know, like, what percent was that raise that she got at work? So if I take my formula, new minus original, the new amount she's making is 12. And I'm going to subtract how much she used to make. So she's now making $2 more. And see how it's a positive this way? So she's making $2 more. And when I divide that by the original amount of money that she was making, here's my difference divided by original. I get 0.2. And I can see that she got a 20% pay increase. Okay? So she's making $2 more. 2 divided by the original 10, 20% increase. All right, I'm flipping over now. We are on the back of our percent of change notes here. And again, like I said, y'all, at any point, if you want to just pause the video and try these on your own, please feel free to do so. Not everybody needs my explanation at this point through the video. So you can even just mute me and let the video play through. And as I'm going through some of the answers, you can kind of just check to see how you did. For those of you who want a little more instruction, here we go. So today the price of a new cell phone is $129. Now back in 2015, the price of a similar cell phone was $240. So I just want to know what the percent of change is in the price of a phone from 2015 to today. So today is the new price. Today is now. That's my new price, $129. And it used to be $240. So when I subtract, I can see it's now $111 cheaper. I'm saving $111 by buying it today. Now, obviously, somebody in 2015 isn't trying to buy it today. I'm just saying that 4 years later, or sorry, 4 years later, 6 years later, here it's 2021 when I'm making this video. This video might be used a little bit later on, so it could be even longer. But from 2015 to today, it's $111 cheaper. And divided by the original price of $240, we can see that that price has decreased 46.25%. And again, this too is not enough to bump this up, so we could say it's about a 46% decrease. And again, you can use either a negative or the word decrease to tell me that. All right, so the next problem, we had 134 people in attendance at a school football game last Friday. And this week, there's 246 people in attendance at the football game. So last week, only 134. This week, maybe there's some hype. Maybe the team's gotten a little bit better. Who knows? Maybe it's a big game. But this week, there's 246 people in attendance. And if I want to see what the percent of change was from one week to the next, I'm just, again, going to subtract. I've got this week compared to last week, so I can see it's 112 more people. And when I divide that by the original last week, we can see here, I mean, it's almost 100% increase. I mean, it's almost increasing by 100% of itself. Not quite. 112 plus 112, that would be a full-on increase of 100%. And that would put us down here at, that'd be 124. So it's not quite. But here we can see when we divide the difference by the original, we get 83.58. And in this case, y'all, the 5 would be enough to round this up. So we could see our attendance is up by about 84%. Attendance is up by about 84%. Definitely a good thing for all the concession stand sales. Now, I love my Biggest Loser problem. I love the Biggest Loser problem, okay? So Biggest Loser, it's a popular show. People try to lose weight. And let's say we've got 2 people here competing, and they're going for 5 weeks. So we've got person A. They started out at 255. And it looks like here they lose 20 pounds. They lose 20 pounds. Now, the other person started out weighing a little bit more and also lost 20 pounds. So the question here is, how does the show, The Biggest Loser, decide who the winner is if both people have lost 20 pounds? And again, that new minus original formula, it's going to show here for person A, they lost 20 pounds, and so did person B. So the question is, who lost more weight? And if we find the percentage of their body fat, that is how we can determine this. So if person A loses 20 pounds out of 255, they have lost 7.8% of their body fat. And if person B loses 20 pounds out of 295, it's not quite as much because their body already weighed more. So losing 20 pounds if you weigh more isn't going to be as big of a deal to losing 20 pounds for the person who weighs a little less. So in this situation, the Biggest Loser is going to say, hey, you won person A because you lost 7.8%, while person B only lost 6.8%. Another way I like to think about that, just in case you kind of missed that concept, let's say I have an adult, this is just a very bad, boring stick figure, and let's say this is their child, okay? Now, this child, let's say the child weighs somewhere around 70 pounds. Now, the adult, let's say the adult weighs somewhere around 160, okay? Now, if this child loses 10 pounds, that is not healthy. In fact, losing 10 out of 70, you are losing a huge chunk of your body weight. Now, if you lose 10 pounds as an adult and you weigh 160, you've got some weight to lose type thing, that's not going to be as big of a deal. So let's just, again, with my calculator, let's compare the kid lost 14.2%, which is kind of a lot, especially at such a young age. And then the adult lost 10 out of 160. So the adult loses 6.25%. See, it's not as much. It's not as much. So here we would say You know, it's not a biggest loser competition, but this person clearly has lost more of their own body weight. And that's kind of what we're talking about here with person A versus person B. Okay, this person lost more of their body weight. So that's why we would say person A is the winner, because 20 pounds is more of their own body weight than person B. Now here we have just a couple more problems. And so for the next to last one, let's say you've got an Amazon gift card and it's $10 off. $10 off, straight up $10 off. So this $10, when would it be a bigger discount? We've got a couple of options here. So you could use the $10 on candy corn, which is 22. Or you could try to save $10 on an electric toothbrush, which costs $64.90. Now, if I'm saving $10, again, there's my difference divided by the original. If I'm saving $10 out of 22, I'm actually saving 45%. Now, if I'm saving $10 of $64.90, I'm only saving 15.4%. So it looks like this $10 off is a way bigger discount on the cheaper item. So remember, you want to use your dollar off things on cheaper items, and you would want to use a % off discount on a more expensive item. And here we are. This one I wanted to review and kind of call your attention back to something that you've already seen. A couple classes ago, we talked about tax, tip, and discount, and you guys had a Google form check for understanding. And you were able to actually answer this question on that Google form because it had answer choices and you could just guess and check by plugging them in. But here I'm showing you that now that you understand how to calculate it, you can actually tell me the discount if you know the original price and then how much it's been marked down to, because we can calculate here the difference. We're saving $49.50. And you can divide that again by the original price. And when you do that, you're going to get a decimal. And when you move that over twice, we can see here that it's 9% off. That was a 9% discount. Okay? So anyways, this is how we calculate percent of change. You've got your new minus original, and what that does is it calculates the difference for you. If the difference is a negative number, clearly you're dealing with a discount or a decrease. If the difference is a positive number, you're clearly dealing with an increase, a percent of increase. Okay? And that concludes this video. Thank you for watching.